testing the soil that you have is going to be really important so that you can figure out how to make the best cob mixture possible with the materials that you have at hand with minimal inputs. And clay subsoil varies greatly in how much clay and how much sand there is. So we're going to do a couple different types of tests. The first test is just testing the soil the clayey subsoil. You never want to use surface soil because it has all sorts of silt and biological matter and stuff. You want to go down under the biological layer and get to the subsoil. And so different soils are going to have different amounts of clay, sand, and straw. So you want to be first doing a test just to see how much, or not straw, clay and sand, how much clay, sand, and silt is in the soil that you have. And then after you have like a rough idea of how much clay you actually have in your soil, you can start doing experiments with making little samples of cob with different amounts of your subsoil versus sand or clay that you're adding in. And the amounts of those different ingredients are going to be informed by the first test, which is called the jar test. So here's how we do the jar test. So first you fill a jar with your clay subsoil, and this came from a construction site, which is often a really good place to be getting a clay subsoil. And you fill the jar about halfway with clay subsoil. And then you add a drop or two of dish soap, and this dish soap is super diluted because my daughter likes to use it and I like to not waste it. So I diluted a lot. So I added several drops. And then you're going to add water, and you add water till you're pretty close to the top. And then I like to stir it first with a spoon, kind of break up some of those clumps. Before I shake it, I'm going to add a little bit more water because as I stirred it up, the water level went down because the water just went in between all of the clay particles. So now I'm ready to shake and shake and shake and shake and shake, 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 shake. And you keep shaking. And then I would normally shake it a little bit longer, but I don't want to bore you unless you really like my shaking. And then after you do the shaking, I like to use a spoon again, or a whisk. Works really well. You could put a whisk in there and just kind of do this with a whisk. And as you can see, I'm using a long spoon. And so I stir it, stir it, stir it. And that dish soap is just helpful for dissolving everything into solution. And then I shake more. And it's important to not fill it up all the way to the top, because if you fill it up all the way to the top, then your shaking will not be as effective at dissolving the clay and the silt. And that's what you're basically doing, mostly dissolving the clay and breaking up any clumps. And I didn't mention this, but you should remove any rocks before you put this in, as you should also remove rocks from any cob that you might be making. So then you're going to let this sit for about 24 hours. So I went ahead and did 3 different soil samples 24 hours ago so that you would be able to see kind of the results and how this works. So the first thing that comes out of solution, that drops out of solution, is the sand. It drops out almost immediately. And then the silt will drop out of solution, and then the clay drops out of solution last because it is so soluble. It really likes to be dissolved in water. And so we did this sample is my clay subsoil here, which is quite clay. This is the mix that I make cob out of, which has clay in it. The silt just comes with the clay, and then with the sand that I add. And this is actually 1 part clay subsoil to 2 3/4 parts sand. And then this is some garden soil that I just wanted to show you, like, you don't really want to use this, but how you might use it if you had to. So with this one, we went ahead and used a tape measure to measure the heights of these different materials. And so we came up with these percentages based on the heights of the different materials, which, you know, this is just an estimate and this isn't like scientific at all, but it's interesting. So with our clay subsoil, I drew a line where more or less the sand stops, and this is pretty clay. I'm calling this silt, but it may even just be clay. And then this is clay. So it's about 9% sand, about 15% silt, and 76% clay. So it's unlikely that you are going to be having a clay subsoil that is quite this clayey, but for our purposes and what we're doing here, this is helpful information. So 76% clay. So the second one is actually the mix that we have come up with out of much experimenting with our clay subsoil. So we import sand, and this sample is made up of 1 part of our clay subsoil to 2 3/4 parts sand. And actually you can see here that that what we have in the final version is about 70% sand, about 5% silt, which the silt is not something like you want or is necessary in it. It just happens to be in there. And then 25% clay. So if you are, if you're sampling your subsoil and you come up with something around 70% sand or 75% sand and 25 to 30% clay, that could be a ready mix, and you might not even need to add any sand or clay to your mix. So this is just kind of a really nice ready mix that I actually didn't just find in my soil. I had to buy a bunch of sand. And then this final test is a garden soil. So this garden soil is very high in the silt. So when I used my tape measure to measure the different proportions, we found that it was about 40% sand, about 50% silt, and about 10% clay. So that is, that's a proportion that is not great, because you want to minimize the amount of silt in your, cob. And so this sample was taken from the surface, and this is something that you will often see if you are taking soil from the surface, is a large amount of silt, and you really don't want that. Like, it's great for gardens. You really want a bunch of silt, but in this situation, you would probably want to import some clay and import some sand in order to make this be a better mix, because otherwise that silt is just going to really weaken the mix. I think having a total of probably up to like 20% silt in your final mix is fine, but 50% is just going to be way too much. And now I'm going to show you how we measure these things to actually come up with these numbers. So I'm measuring this with this tape measure, and as you can see, the total height is about 2 5/8 inches. So I note that we have 2 5/8 inches of sample. And then I'm going to measure the sand, and it looks like we have about 1 3/4 inches of sand. And then I measure the silt, which I like to start at a number like 1 here. It looks like we have about 1/8 of an inch of silt. For the clay, it looks like we have about 3/4 of an inch of clay. So if you're not super mathy, you can just look at your samples and be like, yeah, it looks like we have about 3/4 sand and about 1/4 clay. And that's great for a ready mix. Or, it seems like we have about 50% clay and 50% sand. So we're going to need to add some clay. Or we have like 1/4 sand and 3/4 clay. Seems like we need to add a lot of sand. Or you can get super dorky and mathy like me, and I will demonstrate how to do the math if you don't already know. So here is the dorky math for anyone who's interested. So first we took the sand proportion. So we had 1 3/4 inches sand to 2 5/8 inches of the total. And so then I just converted that into decimals because it works better with a calculator. And for these, I like to use a calculator. So 1 3/4 is 1.75 over 2.625, which is 2 5/8. And again, you don't have to do this. If you're not into math, this is just, if you want to be really precise, you do not need to do this sort of math to be able to do a soil sample. You just want it to be about 3/4 sand and about 1/4 clay. But if you want to do this, you can do 1.75 times 100, because this is 1.75 inches is to 2.625 inches, how some percentage is to 100. So it's 1.75 times 100 divided by 2.625, which ends up being 66. So the sample is 66% sand. And then for the silt, which again, we don't really want silt in there, but it's good to know how much silt we have. So I converted 1/8 over 2 5/8 to decimal points. So that's 0.125 over 2.625. So then we do 0.125 times 100 divided by 2.625, which comes out rounded off to about 5%. It's not 5% over 100, but it's 5 over 100, which is the same as 5%. And then the same thing here for the clay. 3/4 becomes 0.75, 2 5/8 becomes 2.625. So it's 0.75 times 100 divided by 2.625, 29%. And it may be 30. We are not that precise.